I think the challenges are not something unique. It is something which is common to most manufacturers in this space or in the automotive space. And that one biggest challenge is the constantly changing expectation of the customer. Now, when I say constantly changing expectation of the customer, it is not only in terms of product features, but also in terms of quality and delivery. Because quality, once upon a time, used to be considered as you pay higher for better quality, but today quality is considered to be hygiene, and therefore when you have products which are used in a space where it is continuously abused in terms of duty cycles, maintaining those levels of quality which can withstand abuse in terms of the harsh environment and usage is one challenge, number one. Meeting deliveries and also having a transparent value chain from input to delivery. How one can predict this value chain in terms of deliveries to the customer are some of the challenges. So, where you are right now is the global manufacturing hub, and we are in the process of implementing Industry 4.0. Now, Industry 4.0 really is a overused cliche, I would say, and we are in the process of digitizing our processes and creating a smart factory. Now, let me explain what that means. We are actually going live this month on Industry 4.0 incidentally. And we have a team of people working on that. Now, to begin with, as I said, quality. Who was the operator working on the station? So, when we get a complaint from the field, what we know is who was the operator who was worked on the station, what were the torque values, or what were the critical to quality or critical to safety values on that particular station, when was it manufactured, and whether there was any rework conducted on that, who authorized that rework, everything in terms of traceability and genealogy tracking. This is part of the digitization. The other part of digitization is also in terms of maintenance management, where you get a predictive nature of digitization. And what I mean to say is, for example, if a person is not well, he gets symptoms. Now, the symptom is not the disease, but the symptom tells you that you need to go to a doctor. And that's exactly what we're trying to do here. The equipment will tell you in advance that it's not okay and you need to look at something. So that's something like condition monitoring in advance from a predictive nature, so that we don't wait for the equipment to break down and affect our deliveries. So this is part of the Industry 4.0 implementation. On the people front, what we're doing is we are mapping the skills of people to the system, so that we don't put the wrong person in the wrong job. So we have identified the skill levels or skill sets of people, and it will tell us automatically as to who can go and work on which station. The moment he comes in and punches his card, so it will automatically tell him where to go. If he is absent, the system will automatically select as to who is the next best person to work on that station. Now, why this? One, for ease of administration, number one, so that supervisory time is not lost in the beginning for allocation. Second is that defects are not created because of lack of skill on that particular station, so that you always ensure that the skilled person is working and the person who has the knowledge goes and works on that station. So these are some of the, as I said, skill mapping, maintenance management, genealogy, and traceability. These are some of the functions, and also something to do with the backend for helping assembly in terms of tracking the critical to quality parts. Now, we get a lot of parts from OEM suppliers. For example, we get engines, gearboxes, transmissions, and so on and so forth. Now, some of these parts we need to trace the serial number from a warranty perspective. So the person on the line would actually scan the QR code or the barcode on the part, and that will capture the information. So once the product rolls out of the line, it will actually tell you what are the critical parts, who was working on the station. It will give you a kind of horoscope of that machine, the complete information. We're also working on yard management for this. You would have seen a lot of equipments, finished equipments in the finished yard. Now, during a dispatch, how does one go and search? So there will be RFID tags which will be put on these machines, and using a simple tracker, the dispatch person will know where exactly, and he will also be using Google Maps because we are a 52-acre facility here in the GMH to trace that equipment, so that there is no searching time for any dispatch. Traceability, as I said, we use it for part quality tracing, for tracing the person who was the person, and this is not from identifying who did it wrong, but this is to ensure that we can retrain the person and ensure that he doesn't commit the mistake again. So from that perspective, our traceability is important. I feel it's in the south. The challenges are far less as compared to north, and since I've worked in the north as well, the challenges there are more with respect to a social taboo in terms of women going out and working. I don't think we have those kind of taboos here in the south of India, fortunately. If you talk about challenges, it's all again in the mind that women cannot work in an area of heavy engineering is really a myth, because even if it were a man who were working, he's not going to lift those heavy parts. He has equipments like cranes and EOTs to help him lift it. So it's only a mindset. And we found that women are more diligent in terms of when it comes to quality consciousness, and when it comes to, I don't want to sound pro women or something like that, but what I want to say is my observation has been, if a job is given to a woman and if a job is given to a guy, the woman is more diligent in completing the work in terms of even the quality of work. And you know what? It actually kind of creates a peer pressure amongst the colleagues here. That if a girl can do the job, why can't I do it better? So that kind of it kind of creates a healthy competition amongst themselves, and it's a great feeling to have women in a shop floor where there is heavy engineering work happening. It also helps us improve ourselves in terms of providing the right infrastructure to people in terms of ergonomics. And if I can create a workplace, a manufacturing workplace, where even a woman can work comfortably, I think we are in the right path of providing the right ergonomic environment for work. So, absolutely. In fact, we are exploring. If you look at India, we are in a little bit of a paradox, and therefore we need to use technology. And when I say technology, it is especially like something like robots, what you mentioned. We need to use that sensibly. Why? Because one, we have a huge workforce. Now, we do not want to use robots because for the heck of using it. No. Because if we have a bunch of people outside who are ready to work, I think our first responsibility as good employers is to provide employment. Where do we want to use robots? We want to use robots where there could be a possible safety hazard, where working in that environment could create a safety hazard. So we would probably use a robot there. We would probably use a robot where you would need extremely high skills, where it is more person dependent. We would like to make it simpler, and that is something where we would like to use a robot. Where if it is a typical welding on a corner or a niche where it has to go follow a certain path. Correct. So if 2 or 3 different people are going to do it, there is a possibility that. So where we want consistency and where that is something which is critical to quality and the safety of not only the person operating that, but also the person operating the end product. Let me give you an example, not a direct example. Something like a safety critical characteristic could be wheel tightening in a car. The tightening of the 4 wheels in a car, that process is called a safety critical characteristic from an end product perspective. So when a person drives a car, if the wheels are not tightened properly, you can imagine how unsafe or what could happen. So that's called a safety critical characteristic from an endpoint perspective. So something like that which could affect the user of the product. We would like to robotize those kind of processes, especially in the area of building, fabrication. And something where it could be a possible health hazard, we could probably robotize that. And therefore, not only us, I think most Indian manufacturers go for robots for such applications. Typically in the West, our own company in Austria, they use robots in certain areas because their manpower is very expensive. Not only expensive, but there is a dearth for manpower. They don't have trained manpower in Europe, so they get from places like Eastern Europe, etc. We don't have that issue here. We have abundance of trained manpower, and therefore we need to use robots. At the moment, no. If you ask me pure robots, no. But what we have is guided automated solutions for building. But we have ordered 2 robots, which is probably going to be delivered in the next 2 months. We ensure that when the government said absolutely no, we shut our factories. And when the government allowed us to operate with restrictions and conditions, we did it that way. We had a very stringent processes defined, how close people can stand and work, etc. We separated out stations, and what we did is we catered to the critical market needs first and export needs that we focused on first, and ensure that there is proper sanitization that takes place, regular sanitization in the workplace that takes place. And we did there is a term called FMEA, which is failure mode effects analysis, which is a very favorite term. You go to any engineering industry, FMEA is a known word. We did an FMEA as to what could go wrong, and listed down those things, and then one by one addressed what could go wrong, and then ensured those actions are in place so that we could minimize. And I cannot say for sure that we ensured 100%. I mean, no one can say that, but we ensured that we minimized it to a very large extent, the effect of somebody being able to infect someone else. What we do is, to remain competitive in the market, we need to today there's nothing called as loyal customers these days. I mean, gone are the days when there used to be a term coined as loyal customers. Today, if there is somebody not loyal, it is a customer, and that's my personal view. That's because of the only reason that the customer has a choice. If we can't serve the customer, someone else will. So that's very clear. And therefore, there's in today's world, there's nothing called as customer loyalty, and it's even obvious in people using phones. I mean, someone who's an Apple phone user could shift to an Android. So there's nothing called as customer loyalty these days. Same is true with cars, and so is true with us. So what's important is how can we provide the best quality at the lowest cost. This is what the customer expects. Now, we talked about robots and we talked about all these investments here. I want to pause it.
So, yeah.
So, we talked about all these robots and investments and all these things. The customer is not going to pay for this. The customer is not going to pay for his office. Customer is not going to pay for this income, right? So we can't translate these to the customer. He would expect us to give it as the least cost and the best quality. So how do we do it during times when all the commodity prices are increasing? What we need to do is we need to do improvements in our value engineering. We need to do value engineering in our value chain. Something that we have, and that's a separate discussion. A separate gentleman is leading that process called as there's a process called FAIR. FAIR is an acronym for cost reduction in the complete value chain, and it's a structured process which involves all areas, including something like raw material cost, process cost, administration cost, everything, sales and marketing cost. So there is a structured process for that. There are targets taken which are monitored month on month, and each function works on that, and that's how we bring down cost. So that kind of balances the rise in the commodity cost, and that's how we are able to provide at a provide the products to the customer at a, I would say, a reasonable cost which the customer can afford to buy and own the product with.